Okay. This morning we got through the first three of our top 10 list of the greatest discoveries in the history of physics, and those three all came from Greece. And I think you have to give Greece three for the reasons I stated this morning. You have to have the idea of natural science. You have to have the beginnings of extending the power of reason to the universe around us, as Aristarchus did, and then finally extending the realm of math and science to understanding the behavior of earthly objects, which Archimedes did. So now we have obviously a long drought here. I mean, Archimedes was in the 3rd century BC, and the next great scientist on my list is Galileo, at number 4 here, and he did his most important work in, actually, do you remember? Evan.
1620 to 1630.
Yeah, I mean that's actually when he published was later, but he actually did. Remember that the battle with the church held up his publication for quite a while. He actually did his most important work in the first decade of the 17th century, from 1600 to 1610, really. So, but what I want to stress here is not so much Galileo's astronomy, but his physics. And so I'm going to put as my, I want to pick his first big breakthrough in physics as the discovery that I want to focus on, and that is the law of pendulums. Law of, let's say, pendulum motion. And remember, Galileo went through a series of experiments that proved that a pendulum's period, the time it takes to swing back and forth, only depends on its length and not on its amplitude or the weight of the bob or the material that the bob is made out of. Now the reason this was such a huge advance over anything the Greeks did, including Archimedes, was here Galileo is applying mathematical physics, the kind of mathematical physics that Archimedes started, but he's applying it to a subject that Archimedes would not have applied it to. He's applying it to motion. One of the weaknesses of science in ancient Greece was they didn't think that change in the world, motion, was entirely intelligible. And they never successfully applied mathematics to that subject at all. And you can't get very far in physics unless you apply math to the phenomenon of motion, to action of entities. I mean, if you look at Archimedes' laws, they're basically laws of statics. You know, a body just floating in water, or bodies placed on a lever and balanced. They're not laws of motion. Galileo gets the credit for discovering the first laws of motion, which is, like I say, you cannot have modern physics without that. And it's interesting the way he started here. This discovery, which was really the beginning of modern physics, started in a church. I think I told you that story. Yeah, exactly. I mean, he was bored with the sermon and started paying attention to how the chandeliers were swinging. And he noticed a peculiar thing about the breezes that were pushing these chandeliers and causing them to swing, that whether they swung in big arcs or small arcs, it seemed to take the same amount of time. And so he sat there in church, timing the swings of these chandeliers against his pulse. That was the first key to discovering the law of pendulum motion, which then allowed him to discover the law of free fall, so, which led to Newton and so on. Nick? But because he didn't pay attention to the sermon that day? No, they had other reasons for not liking him. But they basically fought him all his life, and it's just ironic that he made his first major discovery in a church. Okay. The law of pendulum motion, I believe he actually came to the law in 1604. It's not when he published it, but when he discovered it. Okay. Who's next on my list? This shouldn't be too tough. Troy. Newton. What would you pick from Newton? Oh, well, what's the most famous story about Newton? Daniel? Yeah, gravity. That's what I picked. Universal gravitation. And this one is the one that would be on everybody's list. This is maybe the single greatest insight in all of the history of science. The fact that Newton could, by grasping this idea that all matter attracts other matter with this inverse square law force, he could, with that one law, explain why the planets orbit the way they do around the sun, why the moon moves around the earth the way it does, why the apple falls down to the ground at the rate it does, why the ocean tides act the way they do, why the earth is shaped the way it is, why it wobbles on its axis the way it does, on and on and on. And by showing the power of mathematical physics, and of course he had to develop a whole new branch of mathematics in order to work out the implications of this idea, the calculus. And by doing that, he really brought mathematical physics, which started in its infancy with Archimedes, he brought it to full maturity now. And it became a leading force in really transforming the world around us. Well, I'll just put the year, not the year he published it, but the year he first got the idea, 1666, when he was only 23 years old. Yes, on a sheep farm. And remember, here's a guy, remember Isaac Newton was the first Newton to learn to read and write. The first Newton to learn to read and write. And he's raised on a sheep farm. And he ends up coming up with an idea that gives rise to the whole modern world. So. All right, now, Newton is the only person in history that I give 2 of the top 10 to. So my number 6 is also Isaac Newton. And, well, I'll give you a hint. Newton published 2 books. Yeah, I'm going to give him one for his optics, too. And Newton's work in optics was, just as he brought mathematical physics to full maturity with his book on gravitation and the laws of motion, he brought experimental physics to full maturity with his investigation of light and colors. And I think the climax of his investigation was the experiment that I told you about with the rings, where, if you recall, I mean, I know I'm going back all the way to last year, but Newton was actually able, through an amazingly clever experiment, to associate each color with a certain wavelength, precisely calculated wavelength. He was the first to discover that. Nick. Yeah, the one with the flat glass, and then the very the barely curved spherical lens on top of it, and then you shine light down from below, a particular color light, say, and you see rings with dark rings. Say if you shine red light down on it, you'll see red rings with dark rings in between them. And by measuring the space between those rings, Newton was actually able to calculate a wavelength he could associate with each color of light. So it's absolutely incredible experiment. But one of the things that did was it turned the whole phenomenon of colors into a mathematical science. And before Newton, people had talked about colors, but it was completely qualitative. They didn't know how to apply numbers to colors. And in the absence of any mathematics, it was just a bunch of vague statements that didn't lead anywhere. And when Newton was able to apply math to understanding the properties of colors, it opened up a whole world that eventually ended up leading us to lasers and all kinds of things. So what I would say Newton's great accomplishment here is he discovered let's just call it the mathematics of colors. And the year on this is 1669. Okay, now who's next? I'll give you a hint. I actually have a pretty big gap here in years until the next entry in my list, till number 7 here. Troy, you want to take a shot? Hmm? Oh, if this were a top 20 list, Franklin would make it, but the top 10 list is really elite. And Franklin, actually, I thought about Franklin's kite experiment, but in the end, he didn't make the cut. He was, so that was 1752. Okay, this is after 1752. Actually, I should just give Daniel credit for this one because he already came up with it. Yeah, you're going to guess Volta and the battery, and that is exactly what I picked. And I'm going to give part credit, though, to Galvani, too. So I'm going to say Galvani and Volta. And the discovery here is electric current. Remember that the whole story that I told you about the dead frogs dancing, and then finally that leading to the invention of the electric battery. And now there's some great work in the 1700s that I've passed over here. including the first, the law of electric force that was discovered by Coulomb, right, which was a great experiment. Coulomb, again, is a guy who would make the top 20 list, but I don't think makes the top 10. And the reason that I pick this electric current is I'm focusing on items that were discoveries that gave rise to a flood of more discoveries. And it turns out you can't do that much with electricity if all you know is electrostatics. The key development here was learning about electric current and learning how to generate it. That was just an enormous step. And it also connects two previously unconnected sciences, which is always an important thing in science. It connects electricity and chemistry. In order to understand the battery, ultimately, scientists had to understand both electricity and chemistry. Okay, so next, I think you should be able to. Who was the next really impressive scientist?
Faraday.
Faraday, right. Now, how would you sum up Faraday's most important discoveries? This was, let's just say, let's put it happened over a number of years what Galvani and Volta did, but let's say the battery invented in 1800. Now, what was the essence of what Faraday did? Evan.
The laws of fields.
Well, he introduced the concept of field, which was huge, but I want a more practical focus as opposed to just stating his accomplishment in abstract terms. Yeah, the connection between electricity and magnetism, even more practical than that. What does that give you? I mean, I could have written it in terms of that, but you're going to take
creating the current in the loop of wire
by turning. Yeah, so that's actually what I want. Remember what Faraday did? He created, in effect, the first little laboratory electric motor where you start with electricity and use it to create motion. And then he also figured out how to turn that process around and use motion to create electricity. So, I mean, this gave rise to so much of modern technology. I mean, if you want to point to a single invention that changed, that gave rise to the later Industrial Revolution and the modern world that you see around you today, this is the discovery. The whole discovering the relationship between electricity and motion. I mean, when Faraday discovered this, he didn't immediately envision, something like Hoover Dam. But on the other hand, there was someone from the government in England visited his laboratory. I don't know for what purpose. Shortly after Faraday had discovered this relationship between electricity and motion, and saw these strange contraptions that he had that were causing wires to rotate when he put electricity through them, and this politician asked Faraday, "Well, what good is that?" And Faraday's response was, "Well, I don't know yet, but I know you'll find a way to tax it someday." And he was right about that. It did turn out to be economically very important. So who's next? Troy?
Maxwell?
Yeah, Maxwell's next. Maxwell for what?
Is the light what light is? Electromagnetic.
Yeah. Yeah, that's what you have to pick, I think, with Maxwell. So number 9 is Maxwell, whose scientific hero was Faraday. And Maxwell had several enormous accomplishments, but if you're going to pick one, you have to pick the relationship between electromagnetism and light. In other words, his discovery that light is an electromagnetic wave. Notice how all the sciences are, so many of these great accomplishments that are on this list are discoveries of connections between sciences that were previously unconnected. I mean, you could say that about number 5 here, Newton's universal gravitation. What two sciences did that bring completely together as one science, basically? Neve? Astronomy and physics. Absolutely. They were two different subjects, really, before Newton. They became one subject after Newton discovered universal gravitation. Nick?
Dates for 8 and 9?
Hmm?
Other dates?
Oh, yeah. Faraday, let me see, put this as 1831. That's when he discovered the principle behind the electrical generator. And Maxwell, I believe this was 1864. Oh, and remember what Maxwell did here. First, Faraday left the whole subject of electricity and magnetism in somewhat qualitative terms. The subject had not been, Faraday was not really a mathematician, and so he didn't work out the mathematical theory of electricity and magnetism. That's the first thing Maxwell did. He cast the theory in terms of mathematical equations, and then figuring out the implications of those mathematical equations, he figured out that electromagnetic waves have to travel with a certain speed. And that turned out to be the speed of light. Right? So that brought two previously unrelated subjects completely together. Optics on the one hand and electricity and magnetism on the other. Now even Galvani and Volta pointed out this was a discovery that brought electricity and chemistry together. And even Newton's optics you can think of as bringing the subject of of colors and mathematics together for the for the first time. Okay, one more. Well, we're whipping right through this, aren't we? I should have stalled more. Daniel.
If I'm wrong, I'm wrong. Is it J.J. Thomson?
It's a reasonable guess. Thomson discovered the electron, right? The first subatomic particle. You know, at this stage, after Maxwell, there's conclusive evidence that matter exists as atoms, in the form of atoms. But nobody knows anything about what these atoms are made up of. And the first big step toward that was J.J. Thomson, who discovered the electron.
Lavoisier?
Oh, you're thinking, well, remember, Lavoisier should be on this list. But I restricted it to physics in order to, because I just couldn't pare it down to 10 if I included chemistry.
And that was Lavoisier. Who was the 12 for chemistry?
Oh, well, it would have to, well, before I say, well, I'll talk about the ones I left out after I finish the list, okay? But let's first get number 10. Troy.
J.J. Watterson?
Oh. Well, if he were to make the list, he would have to have, I mean, since I'm doing them in chronological order, he did his work in the 1840s. So he would be between Faraday and Maxwell. He didn't make my cut. And again, you know, if it were a top 25 list, maybe you might think about giving it to him. But yeah, I had a choice. But what's your reason?
Because he discovered the structure of the atom.
Exactly. See, Thomson, the reason I didn't pick Thomson, even though, well, Rutherford, I picked instead of Thomson. And my reasoning was exactly what Nick just said. Even after Thomson discovered electrons, these negative particles that he could get coming off of atoms, he still didn't know anything about the structure of the atom. And his initial guess turned out to be wrong. And if you're going to pick one discovery here, it needs to be the discovery that gave people knowledge of the structure of the atom for the first time. And that was Rutherford. So and again, this picking Rutherford, Rutherford's discovery of the basic structure of the atom is again a fundamental discovery that lays at the foundation of a whole bunch of other discoveries since then. It just opened up the whole world of the atom for physics to start to explore. Yeah, Nick. Oh, yeah, he, let me see. Well, the experiments that led to this discovery he actually did over a few years, but let's just say around 1910. Yes?
A question about what he did. When he discovered the charge to mass ratio of
Yeah.
the alpha particle,
Right.
an alpha particle wasn't a single proton, was it?
No, it was actually a helium nucleus. So it was two protons and bound to two neutrons. Yeah. So it was actually full. I mean, when they were able to figure out the charges and masses separately, they realized, oh, the mass of this particle is 4 times the mass of a hydrogen.
Okay, so when he started doing the structure, they found that, and then he did the structure with protons.
Yeah, I mean, what he did, remember, he was the one that figured out that atoms consist of this incredibly small, heavy, positively charged particle, and then all these little negative particles, way out, orbiting around it. And then, in subsequent decades, working out the details of that led scientists to a full understanding of the concept of valence for the first time. I mean, we didn't go that far in this class, but all of the chemistry, the 19th century chemistry that we talked about, ends up being explained when physicists completely understand the structure of this atom. And in fact, the subject of theoretical theoretical chemistry, actually disappears as an independent science. In effect, it becomes a branch of physics. Okay. Now you mentioned, hopefully you can see the reasons why I chose these. There are others that, well, first let me answer the question about, if I did throw in chemistry, what would I have to choose? Well, you have to choose Lavoisier as the founder of the science, really. And then the next major development was when they figured out that these elements were atoms and that there was this pattern to their properties, and they could create a periodic table and understand the chemical properties of all the various elements in terms of this periodic table. So that would be Mendeleev. So that would have put me up to 12, and nobody does top 12 lists. So now, this gives you, I think, a good review of what we've accomplished, what we've talked about in the last 2 years. And I think you've probably picked up on the fact that I enjoy talking about this stuff. I love the history of science. I mean, usually when people talk about heroes, they talk about military heroes, or people who put their lives on the line in defense of their values and show tremendous courage. Well, all these guys are my heroes. I mean, not just. I have other heroes, George Washington and Valley Forge and so on. But I think if you think about now what you know about the history of science and the people that made these major discoveries, they were heroes. If you think about Galileo, the kind of opposition that he faced, and he did put his life on his line for his science. And Newton did not face the kind of political and religious opposition that Galileo did. But here was a guy who was born into an ignorant family, basically, on a sheep farm. And through just an incredible effort, comes up with ideas that lead us into the whole modern scientific world. And if you look at history, what you see is the same thing, no matter what area of history that you look into. You see a few people basically dragging the rest of mankind with them as they make progress. And sometimes the rest of mankind doesn't come along for the ride easily. They come along screaming and kicking. And all of these great scientists That is what they accomplished.